We're going to cover today's section 2.2 on page 49, and it's about frequency distribution under graphs. But essentially what we're going to do on this section is we're going to get a visual representation now for numerical data. When we were section 2.1, what we did was getting visual representation for categorical data. Now our problem is that we're going to have numerical data, and we want to get a visual representation. A visual representation. And to do that, now we're going to need to build classes. We need to create classes. So our numerical data is going to be distributed into classes that we're going to create. This is arbitrary. It's up to the researcher to create those classes, and then we're going to be able to get the visual representation. So with the classes, we're going to be able to get a frequency distribution in the same way that we did it when we work with on-categorical data. So let's start with some examples. So, for example, you can see here a table. We have a table here with numerical data, and you can see that now we need to find a way to see this data. So there are a lot of numbers here, and we don't see any indication on how these numbers are behaving or what these numbers are telling us. So we need to create a visual representation of this data set. So that is going to be the purpose of the first example on this page. So we're going to work example 2.7. Example 2.7, which is on page 50. And the example just says that we're going to construct a frequency distribution for the data in table 2.7 using the classes 0.00 through 0.99, then 1.00 through 1.99, and so on. So the classes in this problem are given. So classes are given. Later you're going to see that sometimes you need to create your own classes. So this problem then is about constructing a frequency distribution. So I'm going to write this for our notes. Construct a frequency distribution for the data in table 2.7 using the classes 0.00, 0.99, 1.00, 1.99, and so on. So what we're gonna do is we're gonna create a table as we did before. So we have our classes, and we're gonna do a tally work, and then we're gonna end up with a frequency. So, but this time we don't have a categorical variable indicating, for example, Visa, MasterCard, and another American Express or Discover. So now what we have is the classes that were provided. So we were suggested to use the first class is going to be any value between 0.00 and 0.99. Then the next class is going to contain values between 1 and 1.99. Then we have another class for values between 2.00 and 2.99. Then we're going to have 3.00, 3.99, then 4.00, 4.99. You can stop the these classes until you see that you can cover any value that is in your table. So you need to look for the minimum value and for the maximum value to be able to get the classes that you're going to need to contain all the values that are given in the data set. So I need to include 2 more classes. In that way, I'm going to cover all the values that are given in the data set. So these are the classes that we're going to use, and we're going to distribute all the values that are on table 2.7 into these classes. And we're going to do the same exercise that we did before. So we're going to go through these data values, and we're going to incorporate every value into one of those classes. So we're going to start with 150. So you can see that 150 is going to go, let's see, 150 should go here, and then you put a check mark in 150. Then 0.87 goes here, and you put another check mark. Then 1.12, it goes here, and you put another check mark, and so on. So you're gonna continue with this work. I'm going to give you a couple of minutes to do it, and then you're gonna compare your the frequency that you're gonna obtain with the ones I'm going to obtain. So take a screenshot, just pause your video, and finish the tally work. So we are building a frequency distribution for this data set in table 2.7, which is about particulate emissions for 65 vehicles. So we were doing a tally work, so I hope you finish and you have the same results that I got here. So I have my classes here, and I have the frequencies that I would obtain for each class. So for the first class, I got frequency 9, then 26, 11, 13, 3, 1, and 2. So, and with that, we finished the first example, which is just building this frequency distribution. So something that we can learn from this first frequency distribution is that all classes have the same width. So what is the width? The width of every class is going to be just the difference between these two values. The difference between these two values, the difference between these two values is always the same. So the width of this class is just 1. So, and also every value in the data set, the table that I showed you before, should be included in one and only one class. So you cannot have 2 tally marks for one single value. So you either put the tally in one class or a different class, but the value only is going to have one mark in one single class. So now we're going to do the same thing that we did before. We're going to build also relative frequency distributions by using the formula that we already know, which is the relative frequency for every class is just the frequency of the class divided by the total frequency. So we're going to solve now another example, and that example is going to be example 2.8. So we have now example 2.8, and that example is on page 50, and it's about constructing a relative frequency distribution. So we're going to construct a relative frequency distribution for the data in table 2.7 using the classes, and the classes are the same as in the previous problem. So 0.00 through 0.99, then 1.00, 1.99, and so on. So that's our example 2.8. It's just this example. And you can see here the formula for relative frequency on page 50. So that's our problem. So we're going to use again the same data set that is here, but we already have some work that we have done, so we don't need to start from scratch. So we're going to use the frequency distribution that we obtained in the previous example. So we're going to write, we're going to have again our classes, and we have now frequency, and now we're going to compute the relative frequency. So that's what we're going to do now. So we have the first three classes, 00 through 099, 100 through 199, 2.00, 2.99, and we have 9, 26, 11. Then the other four classes are 300, 399, 400, 499, 500, 599, and 600, 699. So I have my 7 classes. So the last 4 frequencies are 13, 3, 1, and 2. So we're going to sum these frequencies, and we're going to get 65. Use your calculator or use R to see that you're going to get that total frequency. So how do you compute the relative frequency? Using the formula 9 the frequency over the total frequency 65, then 26 over 65, 11 over 65, 13 over 65, 3 over 65, 1 over 65, and finally 2 over 65. I'm going to give you the values. You can check those values by using your calculator. So you're going to get 0.138, 0.400, 0.169, 0.200, 0.046, 0.015, and 0.031. So that's the relative frequency distribution. So that's our problem solved. So now we're gonna learn more definitions that we're gonna need to build our visual representations. Remember, we are just preparing our data to be suitable for a visual representation. So we have some definitions on page 51. Those are the definitions. So we're gonna have now the lower class limit, the upper class limit, and the class width. We have been talking about this, so now we're gonna have our formal definitions. So I'm going to write those formal definitions for our notes, and then we're gonna solve another problem. So these are the definitions that we're gonna get into our notes. Okay, now we have our definitions written in our notes. So we're gonna solve a problem where we're gonna need to identify the lower, the upper, and the class width. The lower class limits, the upper class limits, and the class width. So that is gonna be example 2.9. 2.9, example 2.9 is on page 51, and it says that we're gonna find the lower class limits, the upper class limits, and the class widths for the relative frequency distribution in table 2.9. Table 2.9 is just the frequency distribution, the relative frequency distribution that we obtained from for the last example. So we have here the table, and we also have the table in our notes because that was our previous problem. So The lower class limit. The lower class limit is just the value that is here. 0.00 is the minimum value that you can accept for this class of any numerical value. So that is the lower class limit. The upper class limit is going to be the maximum value that you're going to accept for this class. Then this is again the lower class limit for the next class, and the upper class limit for the next class, and so on. So we're going to write here just the values using the our R notation, just to continue being familiar with the notation that we use in R. So the lower class limits are going to be a collection of values starting with 0.00. Then we have 1.00. If you check the table, then 2.00, 3.00, 4.00, 5.00, and 6.00. So those are the lower class limits. It's just essentially this column of values. Now the upper class limits are going to be the second column of values, or the terminal part, or the terminal boundary of every interval that we use for every class. So in this case, then we're going to have the upper values for every class are 0.99, 1.99, 2.99, 3.99, 4.99, 5.99, and finally 6.99. So those are the upper class limits. Now class width. So the class width is going to be just the difference between two consecutive lower class limits. So you're going to get the difference between these two values. So 1 minus 0, or 2 minus 1, or 3 minus 2. So let's say 3 minus 2, the difference is going to be 1. And if you do it with another pair of values, you're going to get the same result. So 6 minus 5 is going to give you also 1.00. So that's the class width for this problem. So let's continue solving or creating more frequency distributions. Now we're going to play a little bit with the class width. So because remember, I mentioned that the class width is up to the researchers unless it's specified in your problem. So we're going to have now the next example. So it's example 2.10. Example 2.10 on page, let's see, this example is on page 52. So 52. So we're going to construct a frequency distribution. For the data in table 2.7. Now, instead of being given the classes, now we are given a class width of 1.50. So now that's the information that we are given. So this is important to know at this point, the requirements for choosing classes. So this is just what I just said before. So every observation must fall into one of the classes. The classes must not overlap. The classes must be of equal width. There must be no gaps between classes. Even if there are no observations in a class, it must be included in the frequency distribution. And also, you have here in your book on page 52, the procedure for constructing a frequency distribution for quantitative data. So this is just summarizing the steps that we have been following. So first, you need the class width. So again, it can be given. You can have the classes given, or you might need to compute the class width, and that's the problem that we're going to solve a little bit later. So then once you have the class width, you're going to choose a lower class limit for the first class. So to do that, you need to know the minimum value in your data set. Then you're going to compute the lower limit for the second class by adding the class width to the lower class limit for the first class. And then you're going to continue in that way, computing more lower limits until you are able to have classes containing all the values in the data set. So for that, you need to know the maximum value in your data set. So let's work on problem 210. So because once you have the classes, you just get the frequencies. So you do your tally work and get the frequency. So let's work on this problem on example 210. So we have now that the class width is 1.50. So I'm going to write that information. The class width is 1.50. So I need to indicate the classes that this frequency distribution is going to have. So the first one is 00 y, because if you check the table, if you check table 2.7, the minimum value is going to be 0.25. That's the reason we start with 0, and that's the reason that the given classes in previous example also started at 0. So if you can check also the maximum value, when we're going to need this value, is 6.64. So please verify that you can obtain the same minimum and the same maximum value. So, okay, so we know that the class width is going to be 150. So what I'm going to do, I'm going to write the lower class limits first. So I write 0.00 plus 150. I'm going to get 1.50. So I need to write the upper limits, but I'm going to do it once I get all the lower limits. So I'm going to add again 1.50. So I'm going to get 3.00. So I can see that 3.00 is still less than the maximum value. So I need to continue adding 150, which is the class width. Don't forget that. So I'm going to get 450. So that's the next lower class limit. So 450 is still less than 6.64. So I'm going to add 1.50, and I'm going to get 6.00. Still less than 664. So I'm going to add one more time 150. So I'm going to get 7.50. So I'm going to stop there, because now 7.50 is greater than 6.64. So that means that my classes are going to be up to here. But this value is going to be important later when we build the visual representation of the data set. So now we have the lower class limits. So I need to write now the upper class limits. The upper class limits can be written just being sure that you're going to get a value that is less than the next lower class limit. So I need a value that is less than 150 for this case. So I'm going to write 149. And you can write 149,999. So the number of digits really don't matter. So it doesn't matter if you got 49,999 As long as this value is less than this value, that is going to be the only thing that you need to care about. So then for the next one, I need to check the next lower class limits is 3.00. I need a value that is less than 3.00. It's going to be 2.99. And then you can do the same thing that we did before. You just add 1.50 to every previous upper limit, and you're going to get all the corresponding values. So then you get 449, 599, and 749. So you can get all these values, these consecutive values, by adding 150 to the previous value in the same way that we did with the lower class limits. So we have now our classes. So now it's time for us to do our tally work. So we're going to go through the again the table 2.7, and we're going to need to find the where you're going to mark every single value from the data set. So you're going to start with 150. Now 150 goes into this class. Then you have 0.87. 0.87 goes here, and so on. So finish this work, and then we're going to compare our results. So we're going to compare our frequency distribution. So you have here the data set one more time for you to do that tally work. So I have here the frequency distribution that I obtained. So these are my my tally work, and I got 28 and 18, 15, 2 and 2 as the frequencies for these 5 classes. Then if you adapt this value, you should get 65, which is the total number of data values in the data set in table 2.7. And then you can build the you can compute the relative frequencies in the same way as we did before. So we're going to divide 28 by 65, 18 by 65, and so on. So we get these values. So check your work. You should get these results too. Now we're gonna see the last part with respect to building frequency distributions, and this is when you need to find the class width. So on page 53 we have a very important formula. So it's for you to this is for you to compute the class width. The class width for a given number of classes, for a given number of classes. So this is another way to get the classes. So you just think I need 10 classes, so I need 7 classes, or 20 classes. What is the class width? So the first step, you just need to have that number. So you need to decide approximately how many classes to have. How many classes to have for your frequency distribution. Then you're gonna use a formula. So you're gonna have class width is gonna be the maximum value, the largest data value, minus the minimum value in your data set, which is the smallest data value, and you're gonna divide that difference by the number of classes. The number of classes that you are proposing, or that you were required to use. Then most of the time you're gonna get here numbers that are gonna be in decimal format and very difficult to handle. So you need to round the class, and usually you're gonna round this class up. You're gonna round up the value they obtain here. So the result to a convenient value. Convenient value. So what is a convenient value? Usually it's going to be an integer, or it's going to be a number that is going to be easy to handle, because remember, to compute the lower class limits, you're going to add up the class width. So for you to simplify your additions, you better find a class width that is easy to handle, is easy to add up. So we're going to work sample 2.11. So example 2.11 on page 53 is just about using the formula. We're going to find the class width. We're going to find the class width for a frequency distribution, for a frequency distribution for the data, in table 2.7. Again, we're going to use if it is desired to have approximately 7 classes. 7 classes. So we want 7 classes. So that's our first step. Our second step is going to be finding the class width. The class width is going to be the maximum value minus the minimum value over that number of classes. So we know that the maximum value is 6.64, and then the minimum value is 0.25, and we're going to divide that by 7. So use your calculator. It's a simple computation. So, and you're going to get for this 0.91. So you cannot get a class width of 0.91. What is the convenient value to use as a class width? So our class width is going to be round up to 1. So that's what we do in these cases. So now we're going to start with the core part of this chapter, this section, which is, and also from this chapter, because the graphs that we're going to create now are the most important graphs in the entire course of statistics. So we're gonna now study, or we're gonna learn how to create histograms. So histograms are described on page 53, and histograms is just the visual representation for numerical data. So this is the best, the most common visual representation of numerical data. So this is very, very important. So we're gonna need just some information to do it. So we have our data set, or we have our data set, and we're gonna compute a frequency distribution, and then we need some information to get the histogram. So we need to know the number of classes, because the number of classes is going to be the number of bars in your histogram. Number of bars. Then we need boundaries for those bars. The boundaries are going to be all the lower class, the lower limit of every class, of each class, plus one more. So the lower limit for each class plus one more. And we also need midpoints, the midpoints of each class. So we're going to need this information to build our histogram, but also to build the other graph, which is a frequency polygon. And also we need the frequencies, because that's what we plot. We need the frequencies, so we need this information. So we know how to get this information now. So we're going to solve an example. We're going to solve example 2.13. And with this example, we're going to conclude our work on table 2.7. So example 2.13 is on page 55. So let's see page 55. It says about using technology to build a histogram. So we have here on page 55 this problem. We're going to use technology to construct a frequency histogram for the emissions data in table 2.7 on page 49. And there are here guidelines for selecting the number of classes. This is when you are in the real life working your research with researchers, and for many data sets the number of classes should be at least 5 but no more than 20. For very large data sets a larger number of classes might be appropriate. Okay, so at the end of the day what they are saying is up to the researcher to select the number of classes. So we're gonna have then we have here the problem is working again with our table 2.7. So let's see, we're gonna use just the frequency distribution that we obtained before. So I'm going to write here use technology, but we're gonna do this, we're gonna create this histogram also by hand, because it's important that you know how to do it by using just a piece of paper and a pencil. So use technology to construct a frequency histogram. This is going to be a frequency histogram. This is important for the emissions, data in table 2.7 on page 49. So you know that table. I'm not going to show the table one more time. So we have classes 0.099, 100, 199, 2.00, 2.99. So we have also 3.0, 399, 400, 499, 500, 599, 600, 699. So that's our frequency distribution with frequencies 9, 26, 11, 13, 3, 1, and 2. So these are the frequencies. So what we're gonna do now is first we're gonna include one more lower limit. So what is the next one? Is gonna be 7. Okay, because that's the definition that we have for boundaries. So boundaries are all the lower limits plus one more. So this column of lower limits, so this column of lower limits, I'm going to use, let me use my pencil because it's important. So these values here are going to be the boundaries for my histogram. These are going to be the boundaries for my histogram, all the lower limits plus one more. This is important when you use technology. Okay, when you use technology. Okay, so we need the midpoints also. The midpoints. We're going to use a formula, so I'm going to write the formula here. So the midpoints are going to be obtained. So every midpoint is just a lower limit plus the next lower limit, and that is going to be divided by 2. So in this case, I have 0, that's the lower limit for this class, 0.00 plus 1, that is the next lower limit, and we're going to divide this by 2, so you're going to get 0.50. And then you do the same thing. The next one is 1, 0, 0 plus 2, 0, 0 divided by 2 is going to be 150. And once you get the first midpoints, you just need to use the class width. So the class width is, in this case, is just 1. So 2 minus 1 is 1, or 4 minus 3 is 1. So 2 consecutive lower limits is going to give you the class width. So you can just add up the class width, and then you're going to get all the midpoints. So 250, 350, 450, 550, and 650. Or you use the formula. 2 plus 3 divided by 2, you're going to get this value. 3 plus 4 divided by 2, and you get that value. 4 plus 5 divided by 2, and you get that value. 5 plus 6 divided by 2, and finally 6 plus 7 divided by 2. So that there are 2 ways to do it. So you just get the first midpoint, and then you just add up the class width, and that's one way. And the other one is just apply the formula. So now we have all the information that we need to create our histogram. So boundaries is going to be a collection of values, in this case 0, 1, 2, 3, 4, 5, 6, and 7. Don't forget the last one, the extra one. This is the extra one, the extra lower limit for boundaries. For midpoints, we can write midpoints now as a variable. Midpoints is going to be another collection of values. What are those values? Are going to be 0.50, 1.50, 2.50, 3.50, 4.50, 5.50, and 6.50. So those are the midpoints. The frequencies, we know the frequencies. So we can write just frequencies or just frec. So it's up to you. The frequencies are 9 is the first one. It's over here, 9, 26, 9, 26, 11, 13, 3, 1, and 2. So you know how to enter this information into R. So we have boundaries, midpoints, and frequencies. So if you're going to use R, which is the this problem. We're using technology. So the histogram is going to be obtained by using the following command. So you're going to use hist. So you're familiar with this one because you already created a histogram the very first day of classes. So we're going to use hist. Then you're going to use rep parentheses, then midpoints, comma, frequencies. You close these parentheses, comma, then you write breaks equals boundaries, and then you're going to be able to get your histogram for this problem. So and also we're going to do it in a minute. Just let me finish this program. So let's do it by hand first. So when you work by hand, you're going to need to write a sort of rectangular Cartesian system, rectangular coordinate system or Cartesian coordinate system. So you have your x and your y. So your y is going to be the frequencies. You know that the maximum frequency is 26. So you might have here 30, 20, and 10. And then you're going to have the x-axis for your boundaries. So you're going to plot your boundaries. So you have boundaries 0. So you can start 0 here. Then you have 1, 2, 3, 4, 5, 6, and 7. So those are the boundaries. These values are the boundaries that we obtain. And we're going to use a pencil to draw vertical lines. Oh, this is terrible. So I need to do better. So we're going to draw vertical lines at every value, every boundary value. So we draw vertical lines. Now we're going to draw horizontal lines, so using the frequency. So the first class, the frequency is 9, the first class, and the first class go from 0 to 0.99, which is from 0 to 1. So 9 is going to be around here. The next one is 26. So 26 is going to be around here. 26, 9. The next class, the one that goes from 2 to 3, is 11. Then the next class is 13. Then the next class is 3, something around here. 3, 1, and 2. So 3, 1, and 2. And then you just color your bars. You can use different colors. So you're gonna get your histogram now. So that's the histogram. You erase all these guidelines that we used to create a histogram. So this is the histogram using the information that we obtained: the boundaries, the frequencies, and just you didn't use midpoints here. So to get the frequency polygon, you're gonna get a similar plot. So you're gonna have something like this again. So another Cartesian system. You need to write again your boundaries. 0, 1, 2, 3, 4, 5, 6, and 7, and again the frequencies 10, 20, 30. But now you're gonna you're gonna use vertical lines not at the boundaries but at the mid point. So you're gonna have around here a vertical line, around here another vertical line. So these are just lines that are gonna help you to get your frequency polygon. So now you have the midpoints are this one, this vertical line. So now you have again 9 for the first one. So you're gonna have 9 here, a point here. Then you have 26. So 26 around here. Then you have 11 is here, 13 around here. Then you have 3, 1, and 2. And you just join these lines. And that's gonna be the frequency polygon. Doing by hand. So usually you connect this to 0. So that's your frequency polygon. So these are again the boundaries, but these are also the midpoints again. So we needed the midpoints here, and these are the frequencies. So this is going to be a frequency polygon. So we're going to have here a frequency polygon, and here we have our histogram that we did by hand. So it will be good for you to do it also at home for the problem I'm going to assign you later, and get a screenshot of your work that you did at hand and send me that the screenshot along with the screenshot that you're gonna get from your R console. So we're gonna finish now getting the histogram by using R and the frequency polygon, and then I'm going to assign you the problem that you're gonna solve, a couple of problems that you're gonna need to solve. So this is the histogram, and this is the frequency polygon. Okay. So now we're gonna build our histogram and frequency polygon by using R. So first I'm going to enter the boundaries by using the corresponding way to do it. So let's see, we have our console. So I'm going to enter the boundaries 0, 1, 2, 3, 4, 5, 6, and 7. Remember, you have one more value in addition to the all lower class, lower limits for every class. So then we have frequencies. I'm going to use just frec as my variable for frequencies, and those frequencies are 9, 26, 11, 13, 3, 1, and 2. Check my word because I can make mistakes. Then I have the midpoints. I'm just going to write mid. Midpoints are 0.5, 1.5, 2.5, 3.5, 4.5, 5.5, and 6.5. Then we're going to create our histogram by writing a repetition of mid and frec, and this is just a trick to recreate a sort of frequency distribution. And then I'm going to indicate that the boundaries are going to be the break points for that histogram. So that's the histogram, and later we're going to compare this with the histogram that is in the book, but you can compare now the histogram that we are obtaining here with the one that we get by hand. So that's the histogram. Then we're gonna use another display for the frequency polygon, and for the frequency polygon is just plot mid comma frec comma, we're gonna use a type equals quotation mark L. This is letter is important, is an L. I close the quotation mark. L stands for line, and then just I'm going to get the plot, so I'm going to look for the corresponding window. So this is the histogram, and this is the frequency polygon. And you can check both the histogram and the frequency polygon together. So I think we just need to give you the assignment. So let's see. Let me show you the script that I use is here, just in case you didn't have it. So this is example 2.13, and this is also example 2.14. So this is example 2.14. So 13 is the histogram, 2.14 is the frequency polygon. So this is the frequency polygon that we built for example 2.14, and this is the histogram that we built for problem or example 2.13. So we have both examples. Now your work. So you're gonna work on section 2.2 on page 65. We're gonna work the exercise set, and we're gonna work only two problems: problem 32 and problem 34. So you're gonna work on those two problems, and you're gonna send me your work, your screenshots, by using the submit button in the corresponding classwork link. So let me show you problem 32. You have a data set there. So the data set is here. So this is a geyser. So you have all these values. Those are time, so durations in minutes. So you're gonna work on this. So you need to create your frequency distribution by creating your classes. You're gonna follow the directions here to create the corresponding classes, and you do your tally work, you get your frequency distributions, and then you're gonna be able to build your histograms. And then you have to answer these 7 questions. So that's problem 32. So problem 34 is on the next page. Problem 34 is about internet radio. So you have another table, another data set. You need to do to get your frequency distribution, and then you're gonna answer those questions. So that's your work, and that's it for today.